Okay, let's have a look at this one now. Again, usual story here. This is the sum of the sequence an. So we need to look at the absolute value of an plus 1 over an, which would be the absolute value of n plus 1 factorial over n factorial times n squared over n plus 1 squared times x minus 2 n plus 1 over x minus 2 power n. That'd be the absolute value of n plus 1 times n over n plus 1 squared times x minus 2. Now if we take n going to infinity, can we do that just yet? Actually, I can do a bit more cancelling, because if I do not combine here, if I leave this as n plus 1 squared and n squared, I can cancel that with that. So this becomes the absolute value of n over n squared over n plus 1 times the absolute value of x minus 2. I'll divide everything by n squared in the first fraction. 1, yeah, it's going to diverge. 1 over, yeah, 1 over n plus 1 over n squared times x minus 2. This will go to infinity as n goes to infinity, because what will happen is it will become 1 over 0 plus 0. Or you can see it here, the top will grow quicker than the bottom. So this only is prevented from happening unless x minus 2, its absolute value, is 0, i.e. x equals 2. But then the whole thing becomes rather trivial, because then it just becomes the sum from 1 to infinity of 0, which is obviously 0. So this is trivial. So technically it converges in a very trivial way only when x is 0. And we kind of guessed that at the start, because n factorial is going to grow so much faster than n squared.